In this video, we're going to talk about simplifying rational expressions. So I want to start off with a fraction. I'm going to write out 18 and 24 as a product of their prime factors. So 18 is 2 times 3 times 3, and 24 is 2 times 2 times 2 times 3. So I can divide out a factor of 2 from each. 2 divided by 2 is 1, and do the same thing with a factor of 3. And then multiply across. 1 times 3 times 1 is 3. And on the bottom I have 4. Well, I can do something similar with rational expressions also. So let's take a look at this example. Is there a factor I can divide out from the numerator and the denominator? In this case, I can divide out a minus 5. A minus 5 divided by a minus 5 is 1. So multiply across. Now, as a note here, I cannot divide out the a's. These are terms. I cannot divide out common terms, but I can divide out common factors. Okay, so simplifying rational expressions. Factor the numerator and denominator completely, divide out common factors, and multiply across. Okay, so let's simplify each rational expression. So for this example here, let's start with the numerator and factor. I can divide out an a. On the bottom, I can factor out a 4 from each term. So what do you notice? There's a factor of a minus 5. I can divide out from the top and the bottom. And that leaves me with a over 4. Okay, so now let's take a look at the next example. So I want to be able to factor the numerator and the denominator. Okay? So I can factor the numerator and denominator like this. Now, what do you notice? There is a common factor of y plus 5 that I can divide out from the top and on the bottom. So I have 3y plus 4 divided by y plus 1. Again, I cannot divide out the 3's here. Again, I can divide out common factors, but I cannot divide out common terms. Okay, one other example I want to take a look at then. So here in the numerator, I can factor out an x. On the bottom, I can also factor out an x. So I can factor the rest of this like so. Okay, so these x's I can factor out. X plus 4 and 4 plus x are exactly the same. So that leaves me with x minus 1 over 4 minus x. Now, there's one other example I'm going to write out now. Okay, so I want to be able to factor the top and the bottom. On the top, I can factor out a w. And on the bottom, that is a difference of 2 squares. Now, I want to take a look at w minus 3 and 3 minus w. Now, clearly they're not the same because on the top the 3 is negative and on the bottom the 3 is positive. The w is positive on the top and the w is negative on the bottom. But is there a relationship between them? So what I'm going to do is I'm going to take 3 minus w on the bottom and multiply by negative 1. When I do that, that's negative 3 plus w. Well, that's exactly the same as w minus 3. So what I'm telling you is those factors are opposites of each other. So there is a relationship. The deal, though, is when I do this, one of them divides out to be 1, and the other one divides out to be a negative 1. So I will choose to put the negative 1 on the top. So now when I multiply, that's w times negative 1, that's negative w. And on the bottom, I have 3 plus w. Okay? So, the only other thing I want to do here is to write out some opposite factors. So let me do that now. Now, notice with these, the numbers and the variables are the same except for the signs. Here the 9 is positive, here the 9 is negative. Here the x is negative, here the x is positive. Those are examples of opposite factors. So when you divide them out, you're left with one of them being negative 1. All right, I'm going to write out some examples that are not opposite factors now. In order for them to be opposite factors, each term must have the opposite sign. Notice here the x is positive and the x is positive, where here the 4 is positive and the 4 is negative. That is not an example of opposite factors. In this case, both of the 8's are positive, where this is negative x and positive x. Those are not opposite factors. So we'll run into opposite factors in later videos when we multiply and divide rational expressions.